So right now we are present on the global stratigraphic section and point of Permo-Triassic boundary in Japan in the vicinity of Karmra Village. So beneath we have the Mithai formation of Permian age. In this unit of Triassic age, it's called Karmra B formation. And the boundary between these two units is, can be demarcated very sharply over here. These carbonates were, formed on a seamount, so that's why these carbonates are very good candidates for studying the Permo-Triassic boundary, because in Pakistan we have seen a sandstone unit between the underlying Permian and overlying Triassic age, so that sandstone is making a problem. But here you see a continuous carbonate succession whereby this boundary can be observed. You see beneath you have these bioclastic limestone, but when you come closer to this boundary, just at the interface of the boundary, you see these microbialites. So these microbialites are making fenestral fabric, and they are present bedding parallel. Since a lot of organism has been died or extinct, for example, brachiopod and coral, there is a coral gap of 5 million years. Those corals disappeared. The coal on the terrestrial setting, it disappeared. So most of the species become extinct along this boundary. That's why it's got a great dying event or mass extinction. The main cause of this mass extinction along this boundary is Siberian trap, which is a large igneous province, and that is, pumped a huge amount of carbon dioxide into the atmosphere that has caused the global warming and ocean acidification and loss of the niches where the organisms live. Here you see these microbialites are there. These are the organisms which can survive in harsh conditions. So that's why most of the biota, the nictonic and benthonic organisms, those become extinct. But these, organisms, they survive and they make these colonies. The cause could not be a decrease in the oxygen concentration because we don't see any organic enrichment, and secondly, it was a seamount, so there would be oxygen recharge from the water to the seamount. So the cause of this extinction probably could be the high temperature and acidity. This is a very good section in Japan to study. One of the interesting feature along this boundary is you have this planar fenestral microbialite just at the onset of the boundary. But when you go upside, this fenestral fabric changes its shape into a circular shape, algal colonies. And there are two kind of circular algal colonies, one with a very small size and one with a large size. So the Professor Saito has explained this to us that when the energy condition is calm and cool, so these algae, they focus on growing their bodies, so they don't focus on calcification of their bodies because they don't need it, because this calcification is used is a binding force in order to withstand the high energy setting. But when we go up section, we have these storms and tempestudes. That means the energy condition is very high. So there, the size of these microbialite decreases because it focusing on the calcification of their bodies in early stage rather than to grow it. So that's why the size of those microbialites is small. If we compare this section with the section of the China, where you have these large size thrombolite, so just by looking at the size of this section and Chinese section, so that means that the energy condition in China was really small as compared to the energy condition in this area. A lot of storms, a lot of tempestade that has pushed the algae to restrict their size. So you see, also there is carbon isotope negative kick from 4 parts per mil to 0. So it's a 4 parts per mil shift in the carbon isotope, which indicate that a huge amount of carbon dioxide was pumped into the atmosphere by the Siberian trap. So that's all about this section. So we are really thankful to Professor Saito, who brought us here, where we have learned a lot about this Permo-Triassic boundary.